Hey kids. Hope you had a good Tuesday, Wednesday. I don't know which day you're gonna be looking at this. If I look a little scraggly, it's because I'm tired. I did make the bed though. Look, kind of. I mean, ignore the stuff that's on top of it, but the things I'm doing for you guys. All right. So there was one step I kind of jumped over a little bit quickly in the pipeline, and that was the draw call. We sort of just banged that one out, sort of, from the hip. Didn't really think that much about it. So I thought I'd take this just a short while to explain what GL draw arrays actually means and, how that stuff works. So I'm going to go into Paint for this one. I don't know if I can actually fit it. It's like here, a little tiny little. All right, so we're gonna expand it over here. So let's make a little corner for a little corner for ourselves. So I'll do this. How does DrawCall? All right. So the step that I kind of stepped over was the step where we went from single vertices with attributes to linking those vertices together into actual triangles. All right. So that's the step we sort of jumped over. How does that grouping happen? Which groups does it choose and why? And there are a few ways to do this. GL draw arrays, the one we are using, is the simplest one. And there's actually not just one way to do it, even with GL draw arrays. I'm gonna give myself a little bit more space. Excuse me. Okay. All right. So you might have seen the first argument. Went full British. The first argument we passed into GL draw arrays, and that's the GL triangles, and that's the first mode and probably the simplest one to wrap your head around. Let's say we have a bunch of vertices in line here, and with GL draw arrays, it always takes them in order. All right, so when we're gonna consider these algorithms, we're always gonna consider the vertices in order as they appear in the vertex buffer object, so in the VBO. All right, so that's enough. I'm actually gonna copy this as well for the other algorithms. I should have numbered them. Crap. Okay, let's number. This is 0. I'm gonna start with 0, and then we'll do 1, and then this will be 2, and then 3, and then 4, and then 5, 6, 7, 8. I did way too many. 11. Let's copy this down. All right. Excuse me. So the first one is GL triangles. Let's just, I don't even like, let's just write the name. It's gonna be triangles. Excuse me. All right. So the triangles command or algorithm takes each pair of 3 and pairs them together in order. So it will take 0, 1, 2, and make that a triangle. So we'll take the first 3. All right, and then we'll take the next available 3 vertices. So we'll jump. So 0, 1, 2 becomes one triangle. Then it takes 3, 4, and 5. makes that a triangle, and then it goes to the next pairs. It's 6, 7, 8. Whoops. And then 9, 10, 11 for the last triangle. All right. So it just goes 0, 1, 2, triangle, 3, 4, 5, triangle, 6, 7, 8, triangle, 9, 10, 11, triangle. So it splits all the vertices up by 3, and each group becomes a triangle. Okay. Whoops. So that's the first one, and the by far most widely used one. Okay, so this is the one that's used, for models in 3D engines and everything, because it is the most universal. You can make any shape ever using this algorithm. So while I am gonna teach you a few others, do remember that 99% of the time we are going to be using triangles, but I will teach you the other ones in case there is some fringe case where this becomes more useful or easier to makes the implementation easier or cleaner. One is triangle strip. So the triangle strip. I'm just making sure I don't. Yeah, okay. The way this works is that it starts the same with the triangles algorithm. It takes the first 3 and makes a triangle. All right. However, after that, it won't take the next 3. So, 0, 1, 2, it won't take 3, 4, 5. Instead, it will take the last 2 from the last triangle. So we'll start with the last 2 vertices. So we'll start, in this case, with 1, 2. All right, so those are the last 2 vertices of the last triangle. And then I will step 1 further and make a triangle out of that. All right? So 1, 2, 3 becomes the second triangle. All right, and then the algorithm repeats. It takes the last 2 of the previous triangle, 2 and 3, and then joins it with the next one. So 2, 3, and 4 becomes a triangle. All right, and then it repeats. So the last 2 of the previous triangle, 3 and 4, gets joined up with 5. And then so on. And you can see why this is called a triangle strip, because it becomes one contiguous strip of triangles. There is no way to make 2 separate shapes with one draw call using the triangle strip method. All the vertices will always be connected by a triangle in some way. Excuse me. Very good. So that's a triangle strip algorithm. Oops. Let's actually, let's make this a bit bigger. Oh. Come on. Go. Okay. If only there was another paint program I could use. Great. Okay, and another one is triangle fan. Triangle fan. And I'm not actually gonna use like this. Whoops. I'm not gonna use the same example because it's gonna get really messy. I'm gonna use another example. So we're gonna go like that, and then we're gonna go. This could become very obvious why it's called triangle fan. Let's do that. So this is gonna be 0, and then 1, 2, 3, 4, 5, 6. And what triangle fan does is that it starts the same way as triangle and triangle strip. Oops, there it is. Okay, it will join the first 3 vertices into a triangle. Like so. And the next thing it does is it goes first, last of the previous triangle. So consider the previous triangle we drew. Go from the first to the last to the next vertex. All right? So instead in strip it went the two last ones of the previous triangle and then joined it with the next vertex. In this case, we go the first and the last vertex and then the next vertex. All right? And in this case, it becomes 0, 2. That's the first and the last vertex of the previous triangle. So we go 0, 2, and then join it with the next vertex. So this one. Like that. 0, 2, 3. Again, the algorithm repeats. You take the first and the last vertex of the previous triangle, which in this case is 0, is the first vertex, and then 3, and then we go to 4. And as you'll see very quickly, we're making a fan pattern, all right? So first and last vertex, 0, 4, join it with 5. And then again, 0, 5, 6 becomes the last vertex. So you're always making this sort of fan pattern. And, you know, one obvious pattern you will notice is that every triangle is connected to 0. So 0 is always included in every triangle. So I would say triangles, by far most used, 99% of the time using triangles. Triangle strip, fringe cases, for example, if you're doing a line drawer, then so you have maybe a bullet going through space, it might be easier for you to draw that line as a triangle strip. So you're dotting it with vertices in pairs and then joining those together with a triangle strip. Excuse me. Triangle fan. I gotta be honest with you, I've never in my life used triangle fan. Can make a circle quite easily, I guess. But I don't know, I've never used it. Great. So that's the drawing algorithm, or I think it's called draw mode or something. Put this away. Let's actually check it out what it's actually called. So I'll call GL draw arrays. Check it out. Mode. Okay, so it's called the draw mode. And you know, if you look here, there's obviously stuff I have passed over. So here's GL triangles, GL triangle strip, GL triangle fan. There's also stuff like line, GL lines, GL line loop, GL line strip, GL points, GL patches. So there is more to it than that. We might get into lines later, but the important part isn't to understand all of these modes. The important part is to understand how our vertices group together into triangles. That's what I want you guys to take away from this, not exactly how does the triangle fan algorithm work. That's not the important part here. Great. And what is the other two? What is the other two arguments here? So it's first and then it's count. So first means how many. You can think of it in two ways. Either is which vertex are we starting on. So you can imagine if I, instead of doing 0, I said, okay, first it's going to be 1. Then it will actually start at 1. Excuse me, just gonna quit Steam real quick. If it did first as 1, it's going to start at 1 and then go 1, 2, 3, make a triangle, and then the next 3, 4, 5, 6, make a triangle. So you'd see this would get kind of inverted. So that's first. You can also see it as how many are we skipping over? How many vertices are we skipping over? Those are the same thing. Great. And then count. Count is how many vertices are we drawing. So in our case, we put 3, so it will count 3 vertices and draw that. Great. Yes. I think that's it. Cool. So how do we make a quad or a square? Squares are cool. How do I draw those? There was. Let's see if it actually even says that in here. No, they have deprecated because before it was GL quads or quad, and that was taking 4 vertices at a time and making 1 quad, and then taking 4 again and making 1 quad. So we'll just draw quads, but that was never used, as far as I know, in actual game engines, because you're limiting yourself to only using quads, which, you know, if you're rendering a model, most likely there's going to be a triangle or 2 in there, and then all of a sudden you can't render those because you're rendering in quad mode. So, you know, it was one of those things where I'm clever, I will use quads because I'm drawing a cube, and then all of a sudden you're drawing something else than a cube, and you're like, but my cube, it's nice though. So, you know, assuming we can't draw quads, assuming we can only draw triangles, what are some ways that we can draw a quad? Well, if we make up 4 vertices, right? So we'll do 1 vertex here, like this, right? And let's say we just make them in order. We'll do, so it's like 0, 1, 2, 3, like so. That's a quad. Okay, so let's actually do this. Yeah, let's go out of theory land and walk into actual real life. So let's rearrange these vertices to instead of being a triangle, we'll make it a quad instead. So what are the vertices of our quad? Okay, so if we're looking at the NDC, or the normalized device coordinates, we want to have it, these 2 are actually fine. These can stay where they are. We just want to split this vertex up here into 2 additional corners instead of being 1 in the middle. So I'm just going to keep those 2. So they stay. I'm starting bottom right, and then I'm going bottom, we're starting bottom left, and I'm going bottom right. And then we'll go top right. So that is positive, and then we'll go top left, so that's negative positive, like so. And if that doesn't make sense, then I encourage you to draw a square, the NDC square, and actually look at which quadrant our vertex is going to be in and why they be like they do. If you want this to, I'm going to warn you that if you want your example to look exactly like mine, the order is important. I'm just going to throw that out as a hint. Great, so now we have our vertices aligned in a counterclockwise square. Nice. This is the part where I'm trying to like summon thoughts. And it's just like, I'm looking at like the numbers and I'm like, nothing's coming to me. All right, let's, what if I change this to 4 then? All right, so we want to use GL triangles. We don't want to draw 3 vertices this time. We just want to draw 4. Can you guys predict what's going to happen? So you know, it's okay if you're wrong, but make a guess about what's going to happen. Make like a think about how will the GL triangles algorithm handle these 4 vertices. Let's try it out. Oh, And the answer is not really well. We only get one triangle. Still, with this part is just missing. I don't even see this vertex at all. So maybe they did not predict this. That's fine. Let's just step through what happened. All right. So the algorithm went first 3 vertices make a triangles. So let's draw a triangle. That's the wonkiest triangle you ever did see. And then the algorithm continues with the next 3 vertices. So it's going to go 3, 4, 5. However, we didn't specify a 4 and a 5. It only is a 3. And what happens here is the algorithm just quits. It just says there are not enough vertices to make another square, another triangle, sorry. Just quit. We're fine. So that's why we only see one triangle. Great. So how do we fix this? Well, we could just triangle strip, right? Because that's like if we take the first 4 here, that's a square. Like if I would fill this in with like this, that makes a square, right? So what if we use triangle strip? Let's do it. Let's see what happens. So I will do GL triangle strip. And again, I want you guys to predict out loud, what is this gonna look like? It's gonna be a square, it's gonna be a triangle, is it gonna be some other shape? Just make a guess and then let's see what happens. Try to run the algorithm in your head. Okay, so we got this kind of funny square Pac-Man thing. Looks kind of like the Nepalese flag. So okay, so that's not a square. It's actually way complicated shape. Like it's kind of interesting how this seems to be like a vertex in the middle here. So how did that happen? Well, let's step through the algorithm in our heads and try to understand why it's be like it to do. So okay. So 0, 1, 2 is still going to be a triangle, so that's going to be the same. Nothing's going to change there. And then the algorithm goes, okay, it takes the last 2 vertices from the last triangle, so the last 2 vertices from the previous triangle, I should say, and then join that to the next vertex. So it's going to go 1, 2, 3, and then it's going to make a triangle out of that. And ergo, we have our Pac-Man. So that didn't work. We could have been a little more clever with the placement of our vertices to make this work. For example, instead of doing just a complete counterclockwise turn, we could have gone 0, 1, and then go up here, do 2, and then 3. So it's do sort of a zigzaggy. Do sort of a zigzaggy motion. And if we run the algorithm here with a triangle strip, we'll go 0, 1, 2 and makes a triangle. And then we'll take the last 2 from the previous triangle, so 1 and 2, and then join that with 3, and ergo we get a square. If I fill this in, we should get a square like this. But you know, that's just fucking theory. Maybe I'm wrong. I don't know. I've been wrong before. Probably been wrong in this course a few times. So let's try it out. So I'm just gonna move these 2. So I'm just gonna flip these 2 lines. All right. So here you can see we're going minus minus, plus minus. We're going to the right. And then I go minus plus, so I go minus x plus y, so that will be in the top left quadrant, and then I go plus plus, that will be in the top right quadrant. And let's run it and see. Okay, it's a rectangle, but it's a square. Rectangles are like basically squares. Okay, guys, don't quote me on that. But okay, let's see if I pick the resolution 600. But there we go. It's a square. The reason it's a rectangle. It doesn't take resolution into account. It's a normalized unit square, which means that it's gonna get stretched out in the window because the window is not that 1:1 ratio. Rectangles, basically squares. Really tickles me for some reason. All right, cool. But of course, we could have used, instead of doing this like rearranging of vertices, we of course could have just used the fan method, right? So if we don't run this algorithm, whoops, that algorithm on this here square, so we have 0, 1, 2, 3. We'll go 0, 1, 2 as always. Standard start. The straight lines are so hard. Okay, so what does the fan algorithm do? It takes, okay, so from the previous triangle, we take the first vertex and the last vertex. So that's going to be 0 and 2. It takes the first and the last, and then joins that with the next vertex, and that's going to be this one. So there we go. We have another square. It's sounded like a thwomp from Mario. I lost my train of thought. See, the ones that did it in the weekend, it felt so clear, and it felt so, it was like rapid fire. It's like bam, boom, like fucking. I'm passionate. I'm hype. I'm funny. And now during the work days, I'm just like, what the fuck? I'm just drawing triangles and I can't do it. So let's try this, okay? I'm sorry, you'll have to. I'm sorry. I should write a script or something. Okay, so we'll do. We'll put that there. Okay, so now we're going left, bottom right, up, and then bottom right, bottom left. I said that completely wrong. Bottom left, bottom right, top right, top left. So we're going in that direction, and let's try GL triangle. Whoops, GL triangle strip. Fan, GL triangle fan. A hat strip. Fan. There it is. It's a square, or rectangle. So again, it doesn't matter really, that because, you know, again, I've never used fan in my life. Maybe once. Strip I used sometimes when I'm feeling super clever, and then it turns out to be worse than just using triangles. So this doesn't matter. You will never really be considering when to use triangles and when to use triangle strip versus triangle fan. That's not what I want you guys to take away from this. What I want you guys to take away from this is there is a certain way of counting the order of vertices and grouping those together in triangles. The order matters. And just to give you guys a little bit of hands-on feeling for how you consider triangle order for drawing certain shapes. Great. We're going to take one more trip down this. We're going to talk about something called an element buffer, because we're going to talk about that quite obvious shortcoming of the triangles algorithm and how to solve that or how to overcome that. So I'll see you guys next video. Bye.